Hello. The experiment demonstrated in this video is an attempt to illustrate baroclinic energy conversion. Baroclinic energy conversion, as defined in our textbook, describes the generation of kinetic energy resulting from the conversion from potential energy. Term C of the Eddy kinetic energy equation includes this type of energy conversion and is proportional to the correlation between the vertical motion and the temperature anomaly averaged over the volume in question. Using this information, we will demonstrate warm water at the bottom of the jar ascending to the top when a barrier is removed, potential to kinetic. Taking this a step further by changing the temperature of the cold water, we will demonstrate the difference in kinetic energy that is produced due to the change in the temperature anomaly in the jar. The warm water in the cup in the bottom is kept at a constant temperature of 100 degrees Fahrenheit. It is covered with tin foil, and the demonstrator puts a hole in the top of the cup, allowing the colored warm water to flow out toward the top of the cold water. In this demonstration, the difference between the cold tap water and the warm water put at the bottom of the jar is approximately 30 degrees. Again, the warm water in the cup in the bottom is kept at a constant temperature of 100 degrees Fahrenheit. In this case, the difference between the cold water and the water at the bottom is approximately 60 degrees, as the water in the jar this time has been refrigerated. Potential energy exists in both situations because colder, denser water is above the warmer water in the cup. The conversion from potential to kinetic energy begins at the point the seal is broken on the bottom jar, as the warm, less dense water leaves the cup and rises to the surface. Comparing the left and right jars, we can see a difference between the two jars in the way the warm water ascends. This goes back to what we talked about in the beginning. Term C of the Eddy kinetic energy equation relates vertical motion to the average temperature anomaly over the volume in question. This experiment helps to show how, when there is less of a temperature difference, we would expect to see slower ascent. After 10 seconds, the jar with blue coloring on the right has reached the top, but the jar with green coloring on the left has not. Relating this to weather patterns, we can establish that in the summer there is generally less of a temperature contrast between air masses, so term C, the baroclinic energy conversion term, is weakened. In contrast, during the winter, the temperature contrast is greater, therefore the baroclinic energy conversion term is larger. This helps to explain why cyclones are stronger in the winter than in the summer.